Welcome to this channel, and today again I will be doing a question related to control system. This question is again taken from one of the test series. It will be helpful for you in your GATE exam and in other exams also. So let's see the question. So it's written that the root locus branches from the open loop transfer function gs is equal to k over s plus 1 s plus 2 of a unity feedback control system intersects s plane imaginary axis at g plus minus j. So we have to find the value at which uh, the root locus of this function it crosses the j omega axis. So it can be shown like this. So somewhere here, say the root locus, if I draw the root locus, it is somewhat like this. This is at 0, this is at 1, this is at 2. Okay, so from here, if you see, this branch diverges to infinity from here. So, but this is not the part of the root locus, and this is the part of root locus, and here it again goes to the j omega axis. So we need to find this along which we get an intersect along the imaginary axis. So this is the imaginary of s, or you can say j omega axis. So we need to find this point. So this can be done in many ways. So the easiest way to do is using Routh-Hurwitz criteria. So what we can do is we can first form a characteristic equation and then again use the condition such that we get the intersect along j omega axis. So let's start. So k over s plus 1 s plus 2 plus 1. So first I am forming a characteristic equation. So characteristic equation, so it is written as k plus s into s plus 1 s plus 2 is equal to 0. So it is k plus s square plus s into s plus 2 is equal to 0, and it can be again written s cube plus 3s square 2s plus k equals to 0. So now again I can form the route table, and that can be formed as, so again I'll write it s cube plus 3s square plus 2s plus k is equal to 0. So while forming the route table, what you need to keep in mind is first you write the highest power and you proceed to the lowest power. So the lowest power means zeroth power of s, which will be a constant value. So now what you do is you see the coefficient for each power. So here you see the coefficient is 1, and the next is written on the second row. So 3 will be written here. Again 2 will be written here, and again k will be written here. Now what you do is you first multiply these two and you subtract it from these two and divide by this element. So if you do that, you will get 3 into 2 minus k over 3 and 0, because after that there is nothing. So what you need to do is you need to make this row as 0, entire row as 0. So you see from here 3 into 2 minus k over 3 should be made 0. Okay, this should be made 0. So from here you get k is equal to 6. So you see that if you put the value of k equal to 6, then this entire row is going to be 0. Now you see the row above that, so the s squared row, and you can write it as the first element as whatever power you get here. So you can write it as 3s squared plus, now you subtract two powers from s, so 2 minus 2 is 0. So s power 0 into k is equal to 0. So you get 3s squared plus, if you write s power 0 is equal to, it's a constant, so you get a value like this. So now from here you can get s is equal to, s squared is equal to 6 by 3, or s squared is equal to 2 minus 2. Okay, so you get s is equal to under root of minus 2. So this is equal to plus minus j2, j into root 2. So this is our answer. So it will be crossing the j omega axis at s equal to plus minus j2 or plus minus j, if you want to write like this. Root 2 is 0.414. So this is how this question can be done. So you need to just keep in mind that how you need to multiply the different elements and how you need to place these elements. Okay, you need to place the elements as I explained earlier, and then you need to see the row, you need to make the entire row 0 and see the row above that, and it is always going to be a row with even number of powers, and you subtract by 2 powers every time. And so say it was s power 4, so this would be s power 4, s squared, and s power 0. Okay, and after that you can solve it. So thanks for watching.